I'd like to look into a special method to solve integrals called the substitution method. And it can only be used in some very special cases, but it's quite an important rule. In order to really understand it, it's good to have a little revision about the chain rule, because you can only understand this if you have some understanding of the chain rule. So for example, if I write down fx equals e to the power 3x squared minus 1, you should know that the derivative, it's not just e to the power 3x squared minus 1, but you have to multiply with the derivative of 3x squared minus 1, so that's 6x, so the derivative is 6x times e to the power 3x squared minus 1. And that's an example of the chain rule. So normally if it would be e to the power x, you'd say, okay, derivative is e to the power x, but now it's e to the power something, so the derivative is e to the power something times the derivative of that thing in the exponents. So that's one example. Maybe let's do one other example. Suppose you're asked to find the derivative of, let's say, ln 5x plus 4. Well, we know if you take the derivative of ln x, it will be 1 over x. So here we would start to write down 1 over 5x plus 4, but because of the chain rule, we have to multiply with the derivative of 5x plus 4, so times 5. So you can say it's 5 over 5x plus 4. Okay, now I'm going to write down two integrals, and they both have something in common. So let's look at these examples. The first one, let's say, and let's take the second one. Okay. Well, both are integrals. They look rather complicated at first, but they have something special in common, and that may be clear if I indicate these parts in red, and then in blue the 2x minus 1 and the cosine x. And if I ask, well, what is the connection between the part in red and the part in blue? You can easily see that the part in blue is the derivative of the part in red. Yes? So you can actually say that if the part in red will give a name, we will do a substitution, we call that u, then this part is then du dx. So let's see how that substitution can be used to solve the integral. So as I said, we will do a substitution, so the u will represent x squared minus x plus 5, and then the derivative, du dx, is 2x minus 1. And it turns out that after doing the substitution, the integral with x's will change into into an integral with u, which is much easier to solve. So after doing the substitution, what happens? We end up with du dx times u to the power 4 and then dx. Well, now something special happens. The dx cancels out. You may say, can we just do that? Yes, for now let's just say that it's definitely allowed. So you cancel out the dx, and then we have u to the power 4 du, which is very basic integral, although we don't deal with something with x to the power 4 dx, but it's a u, but we can just integrate it and say it will be 1 over 5 u to the power 5 plus c. Yeah? So you just integrate it as if it were x to the power 4 dx, but now everything is in terms of u. This is not the final answer because we want our final answer in terms of x. So then we can write on 1 over 5 and then x squared minus x plus 5 to the power 5 plus c. Okay, let's see whether we can apply the same idea to this integral. So the derivative of sine x is cosine x, so we take sine x to be u, and then the du dx is cosine x. In other words, this integral can be written as du dx root u dx. Of course, I realize that this method can only be applied in some very special situations. Actually, whenever an integral can be written in this form, like there is some derivative involved, du dx, and then the u, it's some function of u. So looking at our two examples, we have the derivative of u times the root of u. Here we had derivative of u times u to the power 4. So if you can discover this kind of pattern in any integral, you may attempt to do the substitution method. Okay, like in the previous example, the dx cancels out, so we can just replace the order. We have root u du. Integrating the root is doable. Let's first write it as u to the power half du, and then, you know, to apply the rule, we add 1 to the exponent. So half plus 1 is 3 over 2, and then dividing 1 over 3 over 2, so 2/3 u to the power 3 over 2 plus c. And then still the last step. You can write 2/3 and then the u, it was sine x, so sine x to the power 3 over 2 plus c. So this is the antiderivative of that.